Hello everyone, so today we'll see how to make a geometry in ANSYS FLUENT Spaceclaim. So let's start our geometry. We'll make a 2D geometry in Spaceclaim and we'll see step by step how to make the geometry. So it is opening. Let's wait till open. Once it will get open, then we'll make since our geometry is in 2D plane, so we'll be using XY plane as our working plane, and we'll make our geometry in the XY plane. Okay, so once it will open, then we'll start the geometry. So here it is open. So in order to bring this plane in XY plane, so we'll click here in the center on the Z axis. Click on this Z axis center here. It will come XY plane. Then click on sketch, this sketch mode here. You can see one pencil icon. Click on this. Then it will come in XY plane. Press Control button. Then press middle mouse button and pull it here. Okay. So now in order to draw now our 2D geometry, select line. Again I will select sketch mode, and then I will draw the line from here. And since our 25 mm it is okay. Again I will press escape button in order to release this line from here, and again start the line from here. Again 25 mm. Okay. Now okay, XY. Now again 25 mm it was. Okay. Now in horizontal direction I need 300 mm. So 300 mm in horizontal direction. Okay, automatically it will adjust, the window will adjust. Now in vertical direction I need 62.68 mm. So enter. Now press escape button. Okay, now from here in horizontal direction I need 58 mm. And then I will join this point with this end. Okay, in order to get the angle between this line, select dimension. Wait, in order to get the dimension, different dimension, press on this dimension icon, select this line. This is 25 mm. Again this is 25 mm. Select this, pull it down 300 mm. Select this, pull it this side, it will come in the dimension. Select this, pull it like this. Select this, pull it like this, then it will come all the dimension. Now in order to know the angle between this line and this line, this green line and this green line, so since I have already selected a dimension, press control, select this one line, press control and select this second line. So it is saying the angle between these two lines are 177 degree. You can see 177 degree means 3 degree inclination with respect to this horizontal line. This line is inclined at 3 degree. Okay, so again I will come at I will make one line at a distance 2 mm, at a distance 2 mm from horizontal, and its length will be 32. Okay, and the distance, the dimension of this point with this line will be 35. So I will write it 35, and that is 32 means total is 37. So now again I'll zoom it. After zooming I will bring this one 1 mm up, 1 mm, enter 1 mm, then 9.8 degree, 9.8 mm in this horizontal direction, so 9.8. okay, again in vertical direction 5 mm, so 5 mm, and joining this point with this point, that is called 34, that is 23 mm. Okay, and in order to know the dimension, pull it, select this, pull this like this, then select and pull like this, and this one 32, and this one 98, 9.8. Okay, so in order to make the mirror, I want this geometry same as below this center line. This we can see this orange line. This orange line is the center line. Okay, and I want the same geometry down also here, same. So in order to make the mirror, go from here, go on this icon mirror. Okay, select this line through which we want to like mirror. Let's say this is our line along with I want to make the mirror. So select this line first, then select this line, then select this line, then select this line, select this line, select this small line. Then you can see now, we can see like all the geometry, everything we got it here. Okay, all the dimensions, everything we got it here. Okay, so in order to know the dimension between this horizontal line and this horizontal line, just we will select both by pressing Control, so we can get the dimension. Okay, so this was our geometry, inside geometry of the strut, and we want to make some cavity. So go to line, just strut is starting just below this line. Okay, just from here. So select here, again go 12.5 down, that is called depth of the strut. In horizontal direction I will go 50 mm, and angle of inclination I will take it as 15 degree. So for 15 degree, since this is 180 degree, you can see here this one it is writing the angle here. Okay, this is 180 degree. I want this line, this line, this black color line to be inclined at 15 degree from the horizontal, means it should be at 165 degree from this part, from here, from this red line. Okay, so at one, as soon as it will come 165, just I will leave the mouse. I will bring it, I will check where it is coming 165, and as soon as it will come 165, I will just leave it there. 160, you can see 163.8, 164, 164.1, 164.5, 164.8. Now here we can see exactly like it is also touching on this horizontal line, and it is, the angle is also mentioned as 185 degree. Okay, so just I will press left click on the mouse, so that it will join with that red line. Okay, so I don't want this line here, so I will, here is a option called trim away, or shortcut is also there in the keyboard. We can press T. If we press T, then it will get activated, the trim away option will get activated. Now select this line, so it will get removed. Okay, so for different purposes we have to do different icon here. This is for line, this is for circle, this is for rectangle, this is for getting the dimension, this is for mirroring, this is for trim, this is for splitting the curve, this is for project to sketch, how to projecting sketch mode, then arc, then this is 3-point arc, this is your ellipse. And after making all this geometry, these are the options. I will explain everything. This I will explain with a different geometries, like how to use all these options. For now, like we are learning how to make this 2D geometry. Okay, so it is completed now, so I will end the sketching. So okay, before that completing, I will just get the dimension, click on dimension, get the dimension of this 12.5, dimension of this. Now in order to go get this angle with respect to this angle, just I will select this line, press Ctrl and select this line, just leave it, it will show the value. Okay, 165 degree. Okay, 165 degree means it is inclined at 15 degree from the horizontal. Okay, and this 177 means it is inclined at 3 degree from the horizontal. Now end sketch editing, I'll press this one. Okay, so once it is selected, now we can update the geometry here. Right click, update. Okay, so now we will do the meshing of this geometry. So left click, edit, so the meshing will get open. Once it will get open, then we will apply the face meshing to the face, to the combustor face. Okay, and once the meshing will get completed, then we will do the name selection to the different faces or different edges. We will apply, we will give some names. Okay, for now we will not go with very fine mesh because it will take very long time to complete those fine mesh and to get those results. So what I will do, I will take some larger mesh in order to just explain to you. Okay, in order to just explain to you, just I will take some larger mesh. So but if you want to do it, you need to do it clearly. Okay, so just I will get this one in our front view. Go to mesh, right click on it, insert, go to sizing, select this full face. Here geometry no selection is option, just click on here, press apply. We can see element size option is there, or here we can get different options. So in element size, I write the element size as, let's say, 5 mm. Okay, for now I am taking at 5 mm, but we will mostly work on very fine mesh. Okay, again go to mesh, insert, and go to face meshing, select this full face and apply. Okay, now select mesh, right click on it and press update button. So once the meshing get complete, we will wait until it get complete. Okay, so here we can see the our meshing is completed. Okay, but since we don't want this much bigger size mesh, we want very fine mesh. So in this video just I'm explaining how to do it. In order to get the more final mesh, again we need to go to face sizing. Instead of 5 mm, you can give very less mm, like let's say 1 mm. Let's say I will show with 1 mm. We can go up to 0 0.14, 0 0.15, 0 0.2, like this mm. Okay, left click, update. So now it will mesh for 1 mm. For different mesh size, we can change the element size and we can check like how much time it is taking and how much final mesh we are getting. If we want more and more final mesh, so we have to decrease the element size. Let's say current in the starting I kept 5 mm, we can keep then I kept 1 mm, we can go more down like 0 0.5 mm, 0 0.4 mm, 0 0.3 mm, 0 0.2 mm, 0 0.1 mm, like this. Now here we can see, as comparison to 5 mm mesh, here the element size is 1 mm, means our smoothness is increased little bit. Here we can see. Okay, like this final mesh will get. So in order to get more and more final mesh, we need to decrease the element size. Let's say instead of 1 mm, here I can keep 0 point, I can keep like 0 0.2, or let's say 0.18. Okay, or if I keep 0.18 mm, it will take really like lots of time. So what I will do, just you can try with more final mesh. Just in order to show in this video, just I'm showing like how to do the how to apply the face meshing and face sizing. Okay, to the combustor face. Okay, this is our combustor, 2D combustor. Okay, so I will not go with very fine mesh because it will take lots of time. In order to just explain, I did this one. Okay, so at how much mesh size I kept, initially I kept at 5 mm, now at 1 mm. Let's, I can keep at 0.9 mm in order to show you more clearly. Okay, then we can go more and more down, like more small mesh size we can keep like 0.14, 0.1, 0.2, like this mm. So as we will decrease the mesh size, that the computational time, like the meshing time will increase. Okay, and it will take more and more time to mesh this geometry. Okay, so it will increase the time, so we need to not worry, because for meshing very fine mesh, it's obvious that it will take very long time. So what we will do, like we'll keep very fine mesh like 0.14 mm or 0. Let's say 0.1 mm, and we'll leave it for some time. Okay, here we can see the message called the mesh translation to fluent is successful. Okay, the mesh translation to fluent was successful. Okay, okay, that, from here we can see the comment message. Okay, and from here we can see the in which unit we are working, like mm, kg, newton. This is our, these are unit, degree, radian. Okay, celsius, temperature is in celsius. Okay, so in order to do the name selection, we will first zoom the geometry. We can see the, if we zoom it, so we can see the meshing here. Okay, okay, so in order to do the naming, we'll go to select this edge, and select this edge. After selecting, we will see that this became green. We can see this became little slight green. Okay, once it is selected, press right mouse button, and there will be option called create named selection. Okay, either we will every time press right click and go to this create name selection, or just we can press n. Here we can see it is writing the shortcut in bracket create name selection in bracket n. Okay, so if we press n, directly we'll get this option. Okay, so this is our, I will write this I will cut this one selection name, and I will write this one is our air inlet. Press ok. Okay, so and this is our outlet, that was our inlet, this is our outlet. Okay, so I will just select this one and press n, because already we have seen like how to do that inlet outlet. Okay, so no need to do it again, and no need to again select that much and go with that. Just I will select those edges and press n. This is our outlet. So this is our upper wall, so select this on both and press n. This is upper wall, or we can do, we will no need to do. Okay, fine, we'll go with upper wall. Okay, okay, this is our lower wall, and this is our lower wall. Okay, and this is our cavity wall, this is our cavity, this one, this one, this one, this is our cavity wall. Okay, and this is our fuel injection from here. So this is our this face, and this face is our fuel inlet. Okay, okay, or fuel injector. Instead of fuel inlet, we can name it as, wait, this is right click, rename, we'll write it as fuel injector, because injector will inject the fuel from here. Okay, fuel injector. This face, this face, this face, all these face are injector wall. Okay, all this face, press n. This is injector wall, okay, press ok. Now we can see it is completed. Now talking about the zone, this complete this, select this face, select this complete face, press n. This is our combustion zone, press ok. Okay, now again we'll go to here, we'll close this Spaceclaim, this is not required now, close. Okay, now we'll update this mess, updated. We can see like it is get updated. Okay, now this was the video like how to make the geometry on Spaceclaim and how to do the meshing on a 2D geometry. Okay, now running about the simulation, already I have uploaded the video for this, like how to run the simulation for this 2D combustor. I will just keep the link in the description box, like how to run the simulations, how to do grid independence test, how to find the XY plot data, how to make the contours, how to run the simulation. Each and everything's are already I have uploaded for this combustor, for this type of 2D combustor. Already I have uploaded for this type of 2D combustor. Okay, so just I will keep the link in the descriptions. Just in this video you can go through how to make the geometry and how to do the meshing, face meshing, and we can decrease the don't go with this much bigger mesh. Okay, like what I have done here, don't go with, just in order to complete the meshing fast, I kept the mesh size very big. Okay, so when you will be doing for your project work, or for your understanding purpose, so go with more finer mesh. Okay, for creating more finer mesh, go to this face sizing, element size is there, down the element size here option is there, you can write the different values like 0.1 mm. It will be better if you go in the order of 0.1 to 0.3 mm. Okay, you can keep any value between 0.1 mm to 0.3 mm, so it will create very fine mesh with number of element will go around like 3 lakh something. Okay, if in my case for 0.9 mm we want to see the number of elements, so go to mesh, click on statics, we can see the number of elements is 21,582 and number of node is 22,049. okay, these are the data for my case. Okay, so already I have done the geometry and meshing, and for how to do the setup, how to run the simulation, how to extract the results, already I have uploaded the video. Just I will keep the video link in the description. So okay, so for this video this much only. Thank you, keep supporting me, like and for more further video I'll keep the update. Okay, so thank you.